RGRல NEET கிளாஸ் படிச்சீங்கன்னா கவர்மெண்ட் கோட்டா சீட் உறுதிங்க. இல்லனா நீங்க கட்டக்கூடிய ஃபீஸ் ரீஃபண்ட் பண்றோம். எப்படின்னு பாக்குறீங்களா? 20 ஸ்டூடெண்ட் தாங்க ஒரு பேட்ச்க்கு. 16 மென்டர்ஸ் வந்து 20 ஸ்டூடெண்ட்க்கு சப்போர்ட் பண்ண போறாங்க. 6 மணில இருந்து நைட்டு 10:30 வரைக்கும் இந்த கிளாஸஸ் போகும். இதுல நீங்க ஒருத்தரா இருக்க போறீங்களா? ஜாயின் RGR அகாடமி.
Okay, today we are going to discuss about Bohr's model and what is the significance of this Bohr's model in the sense the previous atomic models which was proposed by Thomson and Rutherford then explain about the electronic structure of an element. There was a drawback of Rutherford's model as well. This Bohr's model explains how the electronic distributions are there and what about the electronic energy. Each electron carries some energy. What is the energy, whether it is increasing when the distance increases or it is decreasing, everything explained in Bohr's model. So the energy of electron and electronic structure of the atom explained in this Bohr's model. So first we are going to discuss what are the main postulates of this Bohr's model, right? So the first postulate is the electron in the hydrogen can move around the nucleus in a circular path of fixed energy is called orbit. Each orbit has some fixed energy, that is a main thing, and each orbit is also called a stationary state. Why it is called stationary state? In the sense electron revolving in that particular orbit will not radiate or gain any energy. So the energy of electron is constant in particular orbit. If we are changing the orbit, energy differs, but within the orbit the energy remains constant for the electron as well as for the orbit. And the second postulate, the energy of electron in the orbit doesn't change with time. Yes, once it start revolving around the nucleus, it will not radiate any energy. That is a main point. And then electron can move from lower to higher. When it can move from higher to lower or lower to higher, in the sense if it absorbs or emit energy. If the electron is having the lower energy, it will be there in the lower state or any stationary state. When it gains some energy, it will move to any higher level. That process is called what? Excitation. And it can't withstand for a long time in the excited state, because when the energy increases, stability decreases. So it has to come to the lower level to gain the stability. At that time, it has to radiate the energy, it will emit the energy. So based on that only we are having hydrogen spectral lines, right? So the electron can jump from lower to higher or higher to lower, then it absorb as well as emit the energy. What are the things we can able to calculate? In the sense if electron is moving from lower to higher or higher to lower, what is the frequency it emits or what are the frequency of light it absorbs, we can able to calculate using a simple formula. Generally we can able to relate the energy and frequency using the formula E is equal to h nu. But here energy is changing, the transition is happening. So we have to take change in energy for the calculation of nu. So nu can be calculated using this formula, E is equal to h nu. So here energy transition is happening. So we can able to say delta E, which is equal to h nu. So if I want to find out nu, I can derive from this. What is h here? That is Planck's constant. What is the value of h? H, it is 6.626 into 10 to the power of minus 34 joule second. Clear? And how can we find out the delta E? That is the next question. E can be, I told you in the first postulate, each orbit consists some fixed energy. So that can be calculated using this. En is directly proportional to, actually the energy of electron is negative. So we can say it is not directly, it will be like z square by n square. Why energy of electron is negative? That is a very important question. Why it is negative value? In the sense, if electron is near to the nucleus, it will face a lot of attractive force. At that time, due to the attraction, the energy of electron is reduced. When the attraction is there, the stability will increase. So due to the stability increase, energy should be reduced, so it will emit, right? So the energy of electron is negative near the nucleus, and if it is having the hold of nucleus. If the electron is far away from the nucleus, doesn't experience any attractive force, in the sense, the energy will be maximum. What is the energy at that time? It is 0. So the maximum energy of electron which is far away from the nucleus is 0, in the sense when it is near to the nucleus, when it is attracted towards the nucleus, in the sense it will be lesser than 0. So it will be obviously negative value. So that we are having the negative sign here. So RH, it is called Rydberg's constant. Clear? So if we want to calculate the energy in joules, we can substitute 2.18 in 10 to the power of minus 18. If we want to calculate you in the kilojoules, we can take 1312 kilojoule, right? So like that we can change the RH. If you want to calculate in electron volt, we can take 13.6 electron volt. And how to identify this del E in this sense? We have to take the two different level, E2, E1, or we can take E final minus E initial, right? And then fifth one, the main thing, we can able to calculate the angular momentum of electron. The electron is revolving in particular orbit, in the sense it should have the angular momentum, which is an integral multiple of h by 2 pi. So if the electron in the first orbit, n is equal to 1, so the angular momentum should be 1 into h by 2 pi. If it is in the second orbit, the angular momentum will be 2 into h by 2 pi. Like that, the angular momentum of electron in particular orbit will be the integral multiple of h by 2 pi. What are the application of this Bohr's model? In the sense, we can able to calculate the energy of electron as well as energy of orbit, and then we can able to calculate the radius of orbit. If it is nth orbit, what is the formula? In the sense, Rn, which is equal to 0.529 angstrom n square by z. N here it is the stationary level, whatever it is, second or third level. Z represents atomic number, right? And then we can able to calculate velocity of electron as well. Velocity formula, it is 2.18 in 10 to the power of 6 if it is meter. If it is centimeter, we can take 10 power 8. Z by n, here it is not z square by n square, remember it. And then if you want to calculate the total energy of particular orbit, right, En is equal to minus RH into z square by n square. So what are the R value we can include? That is Rydberg constant values. Here the Rydberg constant can differ based on the unit. If I am calculating in electron volt, I have to substitute this. If I am calculating in joules, 2.18 in 10 to the power of minus 18 joule. And if I am calculating in kilojoule per mole, I have to take this. Kilojoule per mole. These are all per atom category. Per mole, in the sense, definitely I will include Avogadro number, so it will be huge, right? And if it is in kilocalorie, this is the formula. Like this, we can calculate in different way. Mainly, we will stick on to these two, right? And if electron is showing transition from N2 to N1 or different energy level, in the sense, we can use this formula. Delta E is equal to final minus initial. So E2 minus E1. So we can derive like this. So the change while we are measuring, it will be energy absorbed or released. So that value will not be negative in the formula I am telling. So here final minus initial, if we are deriving at that time, we will get positive value. And if you are calculating answer at that time, you can get negative. If the energy transition value is negative, means it's exothermic, which means energy released, it can be higher to lower. If the delta E you are getting positive, in the sense, it will be energy absorbed, lower to higher. From that we can find out whether it is a absorption or emission, like that, right? And then we can able to find out wave number. What is the symbol of wave number? That is nu bar. So here we are using the Rydberg constant differently. If we are taking 1.09677 into 10 to the power of 5, the unit will be centimeter inverse, nu bar unit. And if I am taking it in many cases, they will ask you in meter inverse, because then only I can able to find out the lambda. Lambda is equal to 1 by nu bar, no? So when I substitute in meter inverse, I can get directly the lambda in meters, right? And then this is very, very important thing. Whatever we are calculating using the En formula, that is the total energy. So once we calculate the total energy, what is the relation? Total energy is equal to kinetic energy plus potential energy. We are calculating total energy, so that is negative value. If they are asking you kinetic energy, you don't need to go for velocity after that kinetic energy, no. You can directly calculate the total energy. You just change the sign. Kinetic energy is equal to minus of total energy. Total energy value will be negative. So minus minus, it will be positive value. And if they are asking you to calculate the potential energy, you can just multiply it with 2, right? This relation is very, very important for some calculation. And these are all some main concepts, like many will get confused. What is meant by ionization energy or ionization enthalpy? In the sense, if I want to remove an electron from particular orbit, I have to apply some energy. How to calculate it? Whatever the energy of electron, the same we have to apply, right? So ionization energy is the minimum energy required to liberate an electron from a ground state of isolated gaseous atom. And what is meant by separation energy? In the sense, if already electron in the excited state, right? How much of energy is needed to remove that electron from that excited state is called separation energy. Excitation energy, in the sense, if I want to convert the electron from first level to fifth level, how much energy it has to absorb? That is the excited energy. So these are all energy absorbed category, energy needed. So it will be a positive value. So this Bohr's model is very, very important thing, because mainly we will get questions from Bohr's model and quantum mechanical model. What are the limitation of this Bohr's model? In the sense, it's mainly applicable for single electron system. It is not applicable for multi-electron system. And also, the electrons, when it is comes from higher to lower, the emission lines are calculated in the absence of electric and magnetic field. If suppose we are keeping it in electric and magnetic field, it will split into some lines. That is called, in the presence of electric field, the splitting happens. That is called Stark effect. In the magnetic field, if it has happened, that is a Zeeman effect. So Bohr didn't explain about Stark and Zeeman effect. These two are the main drawback of Bohr's model.
12th முடிக்கிறப்பயே நீட் ஜேஇ கிராக் பண்ணணும்னு நினைக்கிறீங்களா? ஜாயின் ஆர்ஜிஆர் அகாடமி. எப்படின்னு பார்க்குறீங்களா? ஸ்கூல் போயிட்டு ஈவினிங்கில் கிடைக்கிற டைமு, சண்டே கிடைக்கிற டைமு நீங்கள் இன்வெஸ்ட் பண்ணீங்க அப்படின்னா உங்களுடைய ஃபிசிக்ஸ், கெமிஸ்ட்ரி, மேக்ஸ், பயாலஜி 4 சப்ஜெக்டையும் கற்றுக்கிட்டு நீட்டையும் ஜேஇயும் அழகாக கிராக் பண்ணலாம். கான்செப்ட்ஸ் கிளாரிட்டி கிடைக்கும், அப்ளிகேஷன் ஸ்கில்லை டெவலப் பண்ணிக்கலாம், ப்ராப்ளம் சால்வ் பண்ணுற எபிலிட்டி வரும். இது மூலயமா உங்களுக்கு நாலேஜ் கிடச்சி அதை அழகாக எக்ஸாம் பேட்டர்னில் ட்ரைனிங்கும் கொடுத்து டெஸ்ட்டும் கண்டக்ட் பண்ணி +2 முடிக்கிறப்பயே கிராக் பண்ண வைக்கிறவங்க ஆர்ஜிஆரில் ஜாயின் பண்ணுங்க. கால் 8695186953.